Vanakkam, Namaste, Namaskar. Back to Jal Prayag. I'm going to continue on the same topic we were doing last video, which was plain sailing. I had finished the concepts, so I'm going to do one problem today. And this problem can be done in two different cases. So I'm going to show the first case today. And in the next video, I will even solve the second case also, because both type of problems come in your exams, and you should be able to do both cases. So I'm going to look at case number 1 today, and let us see. Before I start off, I'm going to just quickly recap. Now, this is the diagram I already told you is a little bit of importance, because if you cannot draw the diagram for your question properly, that means you have not understood the question, and there's a high possibility of you doing mistakes also. So in all quadrantal systems of solving problem which the plane sailing uses, I'll be using an angle which is always 90 or less than 90, it cannot be more than 90. So that means I can divide into 4 quadrants. And the measurement of angle is always done first from either north or south, depending on which quadrant you're. And then you should go towards east or west. And as a recap, on the last sentence, I've clearly written it forms an hourglass figure. There are possibilities of doing mistakes, which I told you last time also. So I'm going to just quickly recap on that. While drawing the diagram, if you forget this hourglass figure, you can draw the triangle completely wrong. That means you will put east-west distance first, and then the north-south. That means you have measured the angle with reference to the east-west. No, that is wrong. And the last word of caution was, since I'm going to use mean lat in these questions, so all my questions should limit myself to 600 nautical miles distance only. Okay, these were few points we had already discussed. Now let us go into the problem directly. I'm giving you an exercise. This, as I said, is a case 1, first type of problem, where he's giving you initial departure position and an arrival position. So my job is to find the course and distance between the two waypoints. I'm going to just give you a systematic approach, because otherwise you have 4 formulas where you will get confused which one to use first and later. And this can end up in wasting your time. So if you are systematic, let us look at what is that systematic approach. Whenever you get A and B, that is initial waypoint and final waypoint, always go ahead and find out what is the d lat between the latitudes and d long. By doing this, the first clue what you get is either the global or local direction. Okay, this is your first clue for starting a question. The moment you get a global and local direction, the next job is to draw a right angle triangle. Remember, we have 4 quadrants, so which quadrant should I do? The answer what you got from this d lat and d long will guide you to form that right angle triangle in that particular quadrant. So this is the approach I am going to do. Once I do this, I have finished my diagram, then I can see what I have, what I don't have, and then we can decide which formula to go and start with. I have 4 formulas which I had shown you. I'll show you once again. So these are the 3 formulas. Okay, there are totally 4. These are the 3 formulas. This 1, 2, 3 formula are directly related to this triangle which I'm going to draw. You can see there are 3 sides and 1 angle. A word of caution again. The theta, which is the quadrantal course, should always be used as degrees and minutes wherever you put in these 3 equations. Otherwise, you'll get errors in your answers. All the sides, convert them into minutes or nautical miles. This triangle is nautical miles, so you can put it in minutes. Now, there's a 4th formula, which is your modified parallel sailing formula. Here also, Now don't get confused with the costs here and costs which is in the first equation. This is cost mean lat. So that means mean lat also should be written in degrees and minutes, and your sides which are departure and d long should be always in minutes. Okay, please remember this, and then let us start the question. Now my first job, as I said, I'm going to find d lat and d long. I'm going to quickly show you in a diagram. We have done all these exercises, so I can be a little bit fast on this. This is the equator. I marked it with blue, approximately 2030. I've shown you the diagram approximately. The value is correct, but the diagram is approximate. Bravo is 1618. Both of them are in the northern hemisphere, so this is Bravo, which clearly tells you that you are traveling in southerly direction. All I have to do is calculate the difference in the value, and it comes to 4 degrees 12 minutes south. Okay, this is important. Now let us go for the D long. Again, I'm going to show you the diagram, same diagrams. North Pole, polar diagram. This is the GMT, and the top one is your international date line, which is 180 degrees. A is 17936 east, so this is A approximately, and B is 178 west, so this is approximately B. Remember, always directions, you can take reference from the Greenwich meridian, and if I go like this, it is called westerly, which is clockwise. If I go anti-clockwise, it is called easterly. The closest distance I can do between A and B is this direction, which matches with easterly. Now, how do you find the value? There are two ways of doing it. There are two ways of finding the D long. I'm going to show you both the ways. Let us look at the first method. I'm very close to 180 degrees. So what I'm going to do is find the difference between A and 180 degrees. It gives me this answer. Then find from B to 180 degrees. This is the answer. So both these differences, if I add them, that gives me the value of D long. We already seen D long is easterly. So 1 degree 52. Let us look at the second method. Second method is slightly easier, but you have to be careful. So I'm going to show you in the second method. All you do is you add the first longitude alpha and second longitude bravo, just add them, and difference from 360 degrees. You will get exactly the same answer. Word of caution, this method, please try to use it whenever you are crossing the international date line or 180 degrees. Okay, that is a word of caution for you. Now, I've got two values already. That is, D lat is 4 degrees south, 12 minutes, and D long is east. So the two letters of the direction south and east tells me which quadrant I'm supposed to draw the triangle. So answer is southeasterly quadrant. So I'm going to mark alpha here. I'll be traveling southeast and reach Bravo. I told you when you draw the diagram, be careful. The theta should be always measured from either north or south. And here it is south. So that means I'm going to put this D lat, which is southerly, here from alpha. And it is 252 minutes because it's a side of a triangle. So it should be in minutes, 252. And the theta is, please remember, measured between this D lat and the distance. Okay. There is a value of D long. Please remember, D long cannot be plotted in this triangle because D long is measured as per definition only at the equator. Now, since I have changed even 1 degree of latitude, we are no more at the equator. So it should be completed with departure. Okay, I don't know the value of departure. And this is your quadrantal course theta. Theta is always measured from south to your particular course line. Okay, it is always from D lat south to your course line. Now, I have 4 formulas. I have only one known figure called 252, which is my D lat. I don't have any other sides. Departure also I don't know. Distance also I don't. So the only one formula for me to start with is we need to find departure. Why? Because I can find departure since D long is given. We have calculated D long. So I'm going to use the formula called departure is equal to d long cos of mean latitude. Okay, this is the formula. I can put d long and I can try to get departure out of it. But I don't know what is mean lat. So my next job is to find the mean lat. We have already done this exercise. Both latitudes are in northern hemisphere, so it's very easy. Just add and divide by 2. You'll get 18 degrees 24 north. Okay. So I'm going to put this in this equation. Departure is equal to d long in minutes, which is 112, and cos of the mean lat. One small suggestion, wherever you get this cos theta, sine theta, and tan theta, whatever it is, please try to take 3 decimals round off so that all answers can match. You can go more, but your calculator might give you 12 to 10 to 12 decimals. So please don't use it. Answers might vary on a large distance. So I suggest stick on to 3 decimals. Should be more than. Now I got the answer as 106.3. So with the fourth formula, which is your departure is equal to d long of cos mean lat, I found out departure. Okay, I'm going to put this departure in the next diagram. One by one, I'm going to put the values, whichever I'm calculating, I'm going to put the values. You can see I've already substituted departure as 106.3, which I found out. Now I have 2 sides. Third side is not known. The quadrantal angle is also not. So what I'm going to do is, let me find the quadrantal angle. I can find the third side also right now also. Choice is yours. So I'm going to go for theta. So for theta, I'm going to use tan theta. Tan theta is equal to departure by your d lat. Okay. So I put 106.3 and 252. Now theta is equal to tan inverse of the same thing. I'm going to get a value. I said put 3 decimals wherever I'm putting a trigonometric equation. Theta is equal to tan inverse of 0.42. Now there is a small word of caution which many beginners do a mistake. They think that tan inverse is 1 by tan theta, which is equal to cot theta. So please don't do this because I'm already finding theta. Theta is on the other side of the equation. So this is wrong. Please don't do it. I've seen many students doing this mistake. So please don't do it. Okay. So theta comes to a value of 22 degrees, 52.5 minutes. And you can see I've added a couple of things. I've added that south and east, which I got from my d lat and d long. And that is how I drew my triangle also. So you can see it is a southeasterly triangle. This can be rounded off to give an answer, but as far as you're using it in any equation, theta should be always written as degrees and minutes. Okay, but I can, for ease, I can change it to decimals also when I'm writing the final answer, but never use this decimals in the equation. So I've given you the quadrantal course as south 22.9, which is a rounded off figure. In 360 notation, I can give it as 157.1 degree true also. Okay. This is the conversion between a quadrantal and a 360 notation. So I found out the course. Now I have d lat, I have departure, I have a course. So I'm going to put that value here. This is the course. Now you have 2 more trigonometric equation and there's one alternate solution also. So I'm going to choose cos theta, d lat by distance. I know the theta, so I can find distance now as 273.6 nautical. Now I have all the 3 sides and I have theta also. Basically, I have completed the question. But I'm going to show you what is an alternate method. I can use Pythagoras theorem to find sides. I already knew d lat and departure. So I can put this equation. I can still find, I will get approximately same answer. There might be just 1 decimal here and there, but it is okay. So you might get 273.5, but still acceptable within the limits. So I can do this. I could have used even sine theta also. So I can use all the 4 formulas. I can use Pythagoras theorem also. Choice is yours. Please choose which you want to. But one small suggestion is try to avoid the equations which have got departure, because wherever departure is involved, cost mean lat is involved. And we know that cost mean lat is the biggest culprit of this equation, where you are taking an average of the latitude, hence you can add errors. So please try to avoid departure in all the equations wherever possible. But if there is no way you have to do it, then take it. Okay, that is my suggestion. So this is my final answer. Final answer is the course is, this is what the course we found out, and distance. So when you finish your question, always please try to give the answers separately in bold and in block format with the units. If you do not write in the theta south and east, your marks may be cut. And the same thing for distance. If you write 273.6, you don't write nautical miles, your marks will be cut. Remember, without the units, there is no value for the figure. So that's the end of this particular module, which I said I'm going to just solve one case of a question. Now, I'll come back to you in the next series of the same plain sailing. I'll be solving one more question, and here I'm going to modify the type of question given to you. So this first type was giving you lat long of A and lat long of B and finding course and distance. I'm going to change the format in the next case of the question also. So 2 cases are more than enough for you to understand what is a plain sailing problem. Please keep watching Jal Prayag. Vanakkam, Namaste, Namaskar. I'll catch you soon with the next one.